So I'm going to be talking about antiderivatives today. So antiderivatives are basically the opposite of derivatives. You do not only like the opposite like operations, but like almost even in the opposite order. Um so for example, if you're given x cubed and you have to take the antiderivative of that, the first step would be to in taking the derivative would be to multiply this um exponent by the coefficient and subtract 1. So I'm going to do the opposite. I'm going to add 1 first, which would make this x to the fourth, and then I'm going to um coefficient of 1 either set up an equation as in 4 times what gives me 1, and in this case it would be 1/4, or I can just multiply the existing coefficient by the new exponent's reciprocal. So basically x to the fourth, and then there was 1 there. So multiply that by a fourth. And that would give me the same answer. The answer to x cubed's antiderivative is 1/4 x to the fourth. Um, Also, if remember that for variables that have a root sign, like a square root, their exponent is a fraction. Like for a square root, it's 1/2. And remember for variables in the denominator, you have to bring that variable into the numerator, and that would make them have that negative exponent. And for both of them, the process is always the same. So an example would be, and by the way, the S symbol symbolizes antiderivative with a dx at the end. So the cube root of x minus 1 over the square root of x cubed plus the square root of 2 over x cubed plus e, and then the s and dx. So the exponent of the cube root of x is x to the 1/3, and I would do the same thing. I would add 1, and that would give me 4 cubed, and I would set up an equation or just multiply by the existing coefficient by the reciprocal. So I'll do that. So it would be 3 over 4 x to the 4/3. For the next one, I would first of all the square root of x cubed, like its exponent is x to the 3 halves, but because it's in the denominator, it has the exponent becomes negative. And I'm going to do the same thing, so I'm going to add 1 to it. So negative 3 plus 2 is negative 1. Ooh. So, and then I'm going to multiply, there was a negative 1 in front here. So I'm going to multiply the existing coefficient by the new exponent's reciprocal, or I could do the equation again, but I'll just do that. So that would be 2x to the negative 1 half um um yeah uh um and then for the next one, um and also, by the way, to check over your work, like for this one, I could take the derivative of this, so then I could do negative 1 half times 2, which is negative 1, and then I could subtract 1 from this, which would be negative 3 halves. So x to the negative 3 halves, or negative 1 over x to the 3 halves, which is basically negative 1 over the square root of x cubed, which was basically the term we started with. So that's how antiderivatives work, and that's how you can check your work. So anyway, back to the problem. Let me erase this. So for the I'm running out of room. I'm gonna transfer this lower. So I can have room. Okay, so for the next one, the square root of 2 over x cubed, again, since it's in the denominator, I'm going to make it the exponent negative, and there's a square root of 2 in front. So I'm going to add 1 to this, which is negative 2, and then multiply the current coefficient with the new exponent reciprocal, or I could do an equation like negative 2x equals the square root of 2 and then solve for x, and that would be my new coefficient. So this would be minus, because of the negative, the square root of 2 over 2 um yeah, um, x to the negative 2. And then for the last term, e is a constant, and so like all constants, if there was a variable attached to it, it would have a power of 0. So if I add 1 to that, now the variable has a power of 1. So, and then if you can do it like there's a 1 in front of here, and so the reciprocal of 1 is 1, and 1 times 1 is 1, or 1 times x equals 1, and then if you solve for x, it's still 1. Anyway, so then it would be plus ex, and hard to see. So like that would be the answer to the derivative, sorry, antiderivative of this function. And then obviously the derivative of this function would be this. And don't forget to add c at the end. I'm moving it up so you can. Yeah. So, I'm going to erase it now. Don't forget to cover the rest of the concepts on the test. And before I get to mention, same thing works with trig, like as you can find the derivatives of trig functions, you can find the antiderivatives of trig functions. So the antiderivative of sine of x is negative cosine of x. And then again you can check, so the derivative of cosine of x is negative sine of x times negative 1 is sine of x. So then cosine of x, and keep the s and dx throughout, is sine of x, and secant squared of x is tangent of x, and cosecant squared of x is negative cotangent of x, since because the derivative of cotangent of x is negative cosecant squared of x, so multiply that by negative 1, it makes this positive. So um so the antiderivative of secant of x tangent of x is secant of x, and the antiderivative of cosecant of x cotangent of x is negative cosecant of x. And again, the same thing. The derivative of cosecant of x is negative cosecant of x cotangent of x. So multiply that by a negative 1 and it makes this positive. So for like these three, you have to keep that in mind. Um, uh, so yeah, that's basically it.